My name is Tarek Madkour. I'm a program manager on the Visual C++ team back in Microsoft in Redmond, near Seattle. I've worked on the Visual C++ team for the past almost 10 years, almost 11 years now. And I have done different things ranging from the compiler, the IDE, the libraries, MFC, all the different things. And now for the past 2.5 years, I've been focused on Windows 8 and what we're doing for Windows 8 mainly. I also do other things on the compiler and the libraries and the IDE, but mostly focused on Windows 8. Now, it's very hard for the past 2.5 years to go home every day and just have to sort of hide your laptop. Nobody can see it, can't talk to anybody about what I'm working on. But for the past couple of months now, I've been able to talk about it, so it's really great that I'm coming greeting great people like you and actually be able to talk about the things that we're doing for Windows 8. So today, I'll talk to you about building C++ applications for Windows 8, how to call into the Windows runtime, the different UI frameworks that we're creating and how to use those, basically how to create great Windows 8 applications using C++, and what is the role of C++ in the whole Windows 8 story. It's not a big crowd today, so you get a lot of opportunities to ask questions. I can probably take a question from each of you. So feel free to interrupt, just raise your hand. I luckily can see you despite the really strong strobe lights in the back. But raise your hand or wave if I can't really see, and I'll stop and take your question. All right, so how many of you attended Katrine's talk this morning where she talked about Metro-style applications? Just raise your hand if you did. Okay, about most of you. Just a few did not. How many did not see anything related to Metro-style applications before? Okay, a couple. Okay, so I'll briefly, just 1 or 2 slides, what are Metro-style applications and why you care. And then from there, I'll talk a little bit about XAML, one of the new UI frameworks that we are new for C++, that we're using for Windows 8. And then finally, I'll actually spend the bulk of the time talking about all those nice Windows runtime APIs. How do you actually call those from C++, okay? So let's get started. Metro-style applications, really quick recap. For those of you who have attended the talks, you'll find this as sort of the focus on the really most important things you should have remembered from the talk. So basically, Metro-style applications are the applications that you can launch from the new Windows 8 start screen that kind of looks something like this. In fact, if you really want to look at it not in a slide, it looks something like this. If I can only get back. Here we go. So you build those applications, it gets an icon on the start screen, and you can launch it. The way that you actually get this application to people is you develop it in something like Visual Studio, then you get a small package, you talk to some people in the Windows App Store, you put that application in the App Store, a customer goes and searches for applications, they find your app, they click, yes, I want it, they either buy it, or if it's free, they just download it, and it goes in their screen. Every time they use it, they're using your application. Every time your application crashes, you log it at the Microsoft server, and we send you crash dumps. Right, so that's the relationship between us going forward. Okay, so how do you create one of those applications, and why did we create a new start screen, and why Metro-style applications, and what is Metro-style anyway? The idea is that we wanted to create experiences in Windows that enable touch-first UIs. For the longest time, Windows was about the mouse and the keyboard. Great applications for the desktop, great applications for laptops. Anybody tried using Windows 7 or other versions of Windows on a tablet? Anybody wants to try it? Well, I can show you one. It works actually, funny enough, in the train station coming here, we were using the online booking system, and it was a touch screen, and it was clearly Windows. I could clearly tell the oldness, probably like Windows 3.1. I don't know, it looked really old. And some people got that working with touch, not the friendliest touch experience. So we wanted a friendly touch experience, an experience that, built from the ground up, that it is not about clicking with a mouse, it's about touching with fingers. The controls behave that way. Everything in the operating system fundamentally behaves that way. Gestures for touch, all of that stuff. We wanted to bake that into the operating system make it available to applications. So that's what Metro-style applications are about, touch-first applications. Metro-style applications are going to be available in all versions of Windows. Windows 8 is not going to be only Metro-style applications. Windows 8 is also going to include non-Metro-style applications. There's going to be a desktop, and you can use that too, right? So the focus of my talk here is going to be how do you create one of those touch-first Windows 8 Metro-style applications that you can eventually put in an app store and have somebody download it and play with it. Well, to talk about that, I'll talk a little bit about Windows 8 anatomy, the anatomy inside Windows 8. And I'll start from the bottom, going up the right, and then we'll go to the center in the middle, okay? So at the bottom, the Windows core operating system. Okay, the core operating system for Windows is pretty much the same. We've added things to it. We've fundamentally changed some things to make experiences like touch work. But you can expect that everything that's been there in Windows 7 and before continues to be there. Namely, all the APIs on the right, Win32 APIs, all the stuff that we shipped in .NET on top of that, Internet Explorer, everything that ran on top of it, all your applications, whether C, C++, C#, VB, websites that ran in Internet Explorer, they will continue to run. So you have a full, complete desktop experience, which is the desktop apps on the right. How many are C++ developers? How many are C# developers? Some people did not raise your hands. How many are not developers? You're all developers, okay. So most of you are C++ developers, okay. So all the C++ applications that you wrote so far should continue to should continue to run on Windows 8. They will run in what's called the desktop. If you want to create new application for Windows 8, you can continue to create new desktop applications for Windows 8. That's absolutely possible. You can continue to update your application for Windows 8. That is also possible. Win32 down at the bottom has been, new APIs have been added. APIs have been modified just like every version of Windows. But the interesting thing, and the part that I'm actually going to be talking about, is the highlighted parts here, which is this whole new set of APIs that we created just for the Metro-style applications. So that was a big focus of Windows 8. We went and created, first of all, we looked at Windows APIs, the state of Windows APIs as they are now. And we said, okay, back in the early 90s, if you looked at the Windows APIs, beautiful, flat C, everything looks exactly the same, homogeneous, feels like it was written by one company, can be consumed by one person, and they only need to think in one way. They don't have to think about different things. Over the years, we've added APIs. We've added different ways to design APIs. We've created APIs in different shapes and forms. We have flat C. We have COM. We have modified versions of COM. We have runtimes that add types of APIs. We've even tried to make C++ friendly APIs in a way that was not binary safe, but we tried to make it binary safe. We have all kinds of APIs, and basically it became an exercise of, if you knew which team at what year developed that API, you would know what the style of the API was. Well, that was not the story we wanted to go forward with. And we really cared about, as you create applications for Windows, you need to have a clean API shape. And how do you go about creating a clean API shape? So we picked, okay, we're going to standardize on one of the API types that we have and actually make it possible for all the APIs to be written that way. In addition to that, we looked at the Win32 APIs that we have and we said, hey, one of the problems that we have is that APIs for Win32 are pretty much only accessible to C and C++. I mean, if you're a .NET developer, you can call them. There's COM interop, there's DLL import and pinvoke and all these interesting things. But APIs range from friendly to kind of possible to like completely hostile. You can't call it with .NET. And that was not a good place for .NET. And if you looked at JavaScript, there was just no way you could call these APIs without having to write like an ActiveX control. Right? So we wanted the APIs more accessible to more languages that we care about. We care about C and C++. We care about .NET. We care about JavaScript. How do we make those APIs available to all languages? So here came the Windows Runtime, WinRT for short. So WinRT was designed such that it's accessible from the languages that Microsoft thinks are important for applications to be written in. And the second thing is they were designed such that all the APIs that you're going to want from your modern application are exposed in that shape and fashion. So when we went about to design WinRT, we did not start from scratch. We looked at the great things that we have and basically adopted, if you're familiar with COM, how many did COM programming? About half, okay? A bit less than half. How many wanted to do COM programming? Not nobody? Okay. So COM programming is nice. COM adds a very nice component model. It's basically a component model that allows you to create objects that can talk to each other and that can be in different modules, and they know how to communicate with each other. That's a very, very, in a nutshell, that's what it's about. And WinRT was, kind of similar what we want to do there. So we adopted some of the paradigms from COM, but COM was too big and too fat. We said, hey, let's just trim it down. And we looked at some of the versions that we have of COM internally, and we said, okay, let's adapt one of these and make that the new basis, and we did. And basically, Windows Runtime was born, and it was born from the shoulders of COM. And it is not exactly COM, but many of the paradigms still live on. So if you were a COM developer and once thought it was like, oh, this was so 1990, it is not. It is back in fashion again. So that knowledge that you had will come in handy. So we created those WinRT APIs, and I'm going to be focusing on how to call those WinRT APIs. And really, it is not that complicated because when C++ was always able to call COM, it just wasn't the prettiest thing to do. So we made it prettier, and I'll talk to you about how prettier it is. And also, we created a UI framework for C++ to use. Actually, we created it not just for C++, but for C++ and .NET. And that was based on the XAML framework, and I'll say more about that in a couple of slides. And that, in a nutshell, is the story of Metro-style APIs in the how to make them. You're using an API and a UI framework, doing some nice C and C++ that talks to a Windows runtime that exposes a beautiful set of new APIs from Windows, and that directly call into the operating system. All done natively, all machine code, highly optimized. So we talked about 3 languages. Well, more than 3 languages. We talked about C, C++, we talked about .NET, we talked about JavaScript. When would you want to use C++? For a while, actually, you didn't hear a lot of C++ coming out of Microsoft, so why are we talking to you about C++ again anyway? Well, one of the things that we notice, and we know exists in the industry now, is that C++ has always had a very strong presence in a number of scenarios. Not only that, C++ is actually an industry standard, and is being used for many, many, many reasons more than we can enumerate. But we tried to capture the essence of what C++ is important for, and we tried to optimize the additions that we're adding to C++ to all play into that strength of C++, or what we think is the strength of C++. And in a nutshell, that's basically about power, performance, and portability. If you think about the current world, for a while, we always assumed that we can have a 300-watt power supply powering our desktop PC that could do as much power, as much damage as you want, and you still would be okay. Your app can run. Use as many cores as you can. Everything is okay. And now we're moving more to a world of smaller devices, phones, tablets, laptops that are no longer okay to have 2 hours of battery life. People really want a 9-hour battery life laptop. So all these scenarios mean that you need to be very frugal about how you're exercising the resources on the machine. You can't just randomly start calling stuff and expecting that you're going to get battery life. So you need a way to exercise that control. And C++ is one of the most, one of the best ways, probably the best way, to have, short of assembly, to go and exercise control over the existing hardware. So that's one really good thing about C++. A second thing is, in C++, you're in control of the system. You know exactly what is happening underlying. There is no other runtime that's under you trying to do things on your behalf. So you can control the performance characteristics of your application. Why is this important? Well, because over the past probably 4 or 5 years, people have started to expect that the UI of applications is getting more refined. That experiences are now more, you're going to hear fluid. The experiences are fluid. The things are snappy. Things do more. You expect that you're going to see a globe and that you're going to be able to rotate it, and that as you rotate it, all the stuff still continues to exist on it. People are expecting more from the applications. And you can always do more, but how can you do more and still stay performant? So if you try to stay performant, that's one of the great things that C++ is about. It's very, very good at managing performance. And finally, we understand that people care about multiple platforms, not just Windows, perhaps, or even within Microsoft. Being on the phone, being on the desktop, being on whatever clients that we have. And C++ has proved over the 20-some years so far to be a great cross-platform tool. So we're rooted in that, and we understand that. So we try to, in our investments in C++, always focus on this. It's power, performance, and portability. These are the things that we really care about. Okay? And similarly, if you think about power, performance, and portability, and think about that in the context of writing Windows 8 applications, applications that are going to need the best performance experience. Basically, the performance experience where as a user, the user is not thinking that the application is sluggish. They're not even thinking about performance. Why? Because it is already performant. They don't have to think about it. You only start thinking about performance as a user when you don't like it. So just take that out of the equation completely. You want these kinds of applications? You want applications that do very heavy calculations, very strong, data crunching or algorithmic stuff? C++ is great. You want applications that are going to run on multiple platforms? C++ is great. So that's what we think people are going to create C++ applications for Windows 8, is because it's capable of these things. So what are the different ways that you can create C++ applications for Windows 8? I talked about XAML really briefly. So we created a new UI framework for Windows 8. It is not new as in no part of it has ever existed before. It is new as in it's finally a way for you to create new UIs that are mainly touch first. And we reused some of the existing knowledge that we had. And one of the good assets that we had was XAML. Anybody done WPF or Silverlight development? A good half of you, okay? So for you not familiar with WPF and Silverlight or XAML, XAML is a very great way to do declarative UI. You have an XML file that describes what your UI looks like, and then through code you manipulate all the stuff that eventually gets instantiated because of what's defined declaratively in the XML file. For you that already know WPF and Silverlight, you'll find that the XAML that we use for Windows 8 is very, very close to, and very familiar to you as a XAML developer already, right? So basically, try to make sure that whatever you've invested in terms of knowledge and teaching yourself something, you can port that. In fact, some of the assets that you already have, you could just take the XAML files and use them, tweak them slightly, and then it works, right? So that was one of the goals. So we created this XAML-based applications. You can create those in C++. You can also create those in C# or VB. One thing that is unique to C++ is DirectX applications. So you could also go and create DirectX apps. Anybody uses DirectX already? 3 or 4. So DirectX is a great way to do 2D or 3D rendering. It's fast. In fact, XAML is implemented on top of DirectX. It's raw down to the metal, but really if you want the thing that is going to be fastest on the screen, like you're doing a game, for example, DirectX, nothing beats that. So you can create DirectX applications, whether you want those for a game or whether you want those for a rendering service. You're doing some CAD application and you want the user experience to have a lot of polygons moving around and layers and depths and shadows and lights and all these interesting things. Can do that very nicely with DirectX. And lastly, C++ has a space even in JavaScript applications. So when we looked at JavaScript and we said JavaScript, we want to enable JavaScript to be able to call directly into the operating system. Well, why would we want to do that? Well, the reason we want to do that is if you think about all the web applications that exist today, opening the door for them to use native operating system services like Find My Location or whatever it is, that's very valuable. Well, what if not only did we allow JavaScript to call into the operating system facilities, but also allow it to call to any random C++ component that you can create to, let's say, you want to do the number crunching thing in C++. You can't do that really fast in JavaScript. That's fine. We have a way for you to do that. So a third way of create C++ belongs in Windows 8 is one of those JavaScript applications. And this JavaScript application can have a single C++ component or multiple C++ components, and it would be able to call into those. So you can think of the Windows runtime as a way for you to also create your components, not just the way to expose Windows 8 components, right? So for the sake of this talk, I'm not going to go into DirectX or JavaScript, but I'll just spend a few minutes first about XAML, then we'll talk about the actual language of calling Windows runtime. So XAML personally is near and dear to my heart because for the longest time I actually owned C++ UI frameworks, and one of those lovely. Anybody done MFC? About half. Okay, nice. Anybody still using MFC? A few. Okay. So for the longest time, people would ask us, okay, we're C++ developers. What do we use to create our UI? And in 1995, there was a very clear answer. What are you talking about? MFC. We would tell some people, yeah, well, if you really want, you can do these things in Win32, but really it's MFC. 2000, we probably about said the same thing. 2003, 2004, we weren't really investing in MFC a lot. You heard a lot of .NET from Microsoft, and if you asked us, what should you build your UI in, we didn't have a very good answer. And sometimes we'd point at .NET and say, well, maybe Windows Forms. And then in a couple of years, we said, oh, not Windows Forms, WPF. Then in a few years, it was, well, maybe Silverlight. Well, we don't really know. So it was a very confusing place to be in. So we were really looking forward to something from Microsoft that is going to be the next generation UI framework. One of the things I know, having been in Microsoft for a while, is what we ship in Windows, we support forever. It is really rare that we put something in Windows and next release go and tell you, you know what, that one was the old one. Here's the new one. Things in Windows really stay for quite a bit. And that's one of the reasons why I'm very excited about XAML, is that we're adding a way for you as a C++ developer to go point at the UI framework and say, this is how I'm going to create my applications. And you know that this is going to be supported by Microsoft for quite a few years. The second reason I really love XAML is that there's a lot of tooling that already exists around XAML that coming from Microsoft. So very nice and fancy designers and editing tools and code editing and all of that that makes your story very simple as a developer. So we basically brought all of that to C++. So basically your editing experience in C++ or your design experience in C++, when it comes to XAML, pretty much as good as what you got with C# or VB. And it is as good as what you get with C# or VB today in Windows 8 as well. So that's something I'm very, very excited about. So enough talking about the values of XAML and the UI framework, and let me give you just a quick demo of what that looks like, what you can create with it. So this is an app, a Metro-style application created with C++ and XAML. Mind some problems that might happen while I run it. Just before I got in, I had to change my resolution, and things started crashing on me. That using a resolution I had never used before. One of the requirements for Windows 8 is that there has to be a certain screen size. And this is a pretty early release of the designer that assumed that, of course, all screens are going to have to at least be that minimum size. Well, the resolution we had to run with was a bit smaller, so things didn't behave as expected. So hopefully I fixed it and everything will work now. But if it doesn't, it's all right. It's just a demo. So if you look at this screen, this is actually basically a designer. This is the designer, the equivalent of the resource editor. Anybody use the MFC resource editor? This is the MFC resource editor taking a lot of steroids. Really, really much improved. So similar, you can. There you go. Did I just close it by mistake? I'm sorry. Just go back and start it again. I apologize for that. So basically, you'll see that on the top we have the designer that's currently loading. In the bottom is actually a full editor, which is a an XML editor, and it allows you to edit the XAML file directly. So you can have both the direct control from a source code, style editing, or you can have the drag and drop experience at the top. The drag and drop experience at the top means you can, click on something like this, move it around, go and get the toolbox, look at the controls, add a button, do all the kinds of things that you expect. Touch one of these things, look at the brush, see what color it is, modify the color, do all of that. Can build this application, which is going to take a while now because I touched everything. But basically, what we give you is a complete edit, build, and debug experience. So basically, you're using C++. We just put a new UI framework on top, and everything that this UI framework needs comes with that. You can actually create one of these applications just by going to File, New Project. Well, I'm building now, so I won't be able to. But if you went to File, New Project, you'll see a list of applications. One of them is just Windows 8, runtime application. I can't even remember what we called it in the build preview that I'm using here. We've changed the name since. And basically, that allows you to create a bare bones, empty one of those. Then you can drag and drop things like that and put them on it. What we also enable is for you to build it. So while you're building, so when we generate the code, we show you. We generate a XAML file. Each XAML file, if you expand that, you'll see that it has a .xaml.cpp file and a .xaml.h file. These are basically the code that you write to use that XAML. So each XAML file contains a UI for, say, a page, and the code that we generate is in a different file. You don't see that, but the code that you use is up there. Did I do something funny with this? I'm sorry. There you go. Changing resolutions for you. So here, if I look at this, yes, I want to open it. If you look at this, you'll see this is the code that I write to use the XAML file. Okay. If I open the header file, you'll see that my header file, which basically includes some things related to the home page that I created, uses a homepage.g.h file. The homepage.g.h file is actually a file that was generated by the build system. If I right-click on it and open that, when I actually build, when I execute the build command, the build system goes and looks at that homepage.xaml file, parses it, understands exactly what kind of UI layout I want, and then starts generating Windows Runtime classes out of that gets included in my project. And then in my code, which is the normal .xaml.cpp and .xaml.h files, then I can actually use those. The nice thing about that is there's complete separation between the designer code and your code. No longer, comment, please do not touch this part of the file anymore. It's just a whole file. You never want to touch it. You never want to look at it. But as a C++ developer, because you actually want to know how things are implemented and how things are working, you can actually go inside that file and look at it. And you know that it is pure C++. It's just pound included from your header file that you actually author and write and edit, right? So whatever it is that we generated, we put in the header file that we ask you to include in your file. Apart from that, there's no magic going on. Then you can go. I thought I just built it. Maybe I just touched something. Then you can just go and just execute that application and run it. So here it's deploying, and it's going to be going in the desktop, I hope. So we provide two kinds, actually three ways to launch the application. One way is what's happening right now, which is you just launch it full screen in your on your computer, right? The other way is taking a while for some reason. I'm pretty sure I did something with the resolutions there. But every Metro style application launches in full screen. That's how it works, right? Which is great in terms of a customer using the application. It's just not the best way for you as a developer to debug applications. Just Alt-Tab, back to Visual Studio, step a couple of things. Every time you're stepping, it's switching on you. It can drive you crazy, But it's there if you actually want to go and do something. Like here, I want to see. I'm pretty sure one of those is going to crash something. Okay, that was too loud. All right. This is basically just a piano. There's actually a story. This is a real application that people on our team have been working on as a sample. The reason we wanted to create this piano application in C++, somebody would say, like, why create a piano application in C++? That can easily be done in any language. Which part of that is either power performance? I mean, maybe portability, I can see that. But which part of that is power performance, right? Well, this particular application actually is not just a piano that allows you to write and play with notes. It also has a listening component. And the listening component allows you to load one of those, look up on the top, it says speedball. You can load an XML file that defines the notes for a song, and then it can listen through your tablet's microphone. You can put that tablet on your real piano, play the real piano, and it will actually listen to how close you are to the notes that are actually being defined. So for you to actually do this kind of runtime analysis of music, to figure out how close it is to a list of notes that you have, you could try doing that in many languages if you want to do something that is pretty performant. You're probably going to look at C++ at least. So that's one of the reasons we created in that. Anyway, I was hoping that the app would actually crash so I can show you that we can debug, but I'll spare you that for now. So I said there are 3 ways that you can run your application. The other 2 ways are, so we did the local debugging. There is simulator debugging and remote debugging. Okay, simulator debugging allows you to run it in a little window that simulates a tablet, and remote debugging basically allows you to run it on a real tablet. I don't have a real tablet with me, so we'll just try simulator debugging. Right? I just change it to simulator, then I can click debug here, and that will actually go and launch it. In the simulator. So I'm deploying it to the simulator, copying it. The simulator is basically a local program that is deployed with Visual Studio. You get it with Visual Studio. It's part of Visual Studio. And when your application runs, it runs in the simulator. The simulator has some really nice characteristics as well, which is, let's say your application wanted to respond to touch, and your desktop doesn't necessarily have touch. The simulator actually allows you to do just that, simulate the touch experience. Started in the background. So this is your same application, just started in a simulator, and these are the different things that you actually add. You can do something like, change it to portrait mode. It's very hard to get your desktop and actually turn it around, and if you did, actually, your computer probably wouldn't do anything. But you can actually simulate what your app is going to look like with something like this. So this is in a nutshell what Visual Studio provides with XAML. You get a first-class development experience that includes designers, simulators, and the whole gamut to actually build great Windows 8 applications. Okay. So we've talked about one of the things that Windows Runtime provides is a great UI framework. What else does Windows Runtime provide? Well, pretty much it provides APIs in almost anything you would want, much like Win32. Quite a number of APIs, thousands. So how do you call these APIs? We've got 2 options. C++, we always like options. I'll give you 2 options. I'm going to start with option 2 first. Why am I going to start with option 2 first? It's because the one we actually use inside Windows. And I'll tell you why we use it inside Windows. So option 2 is using what we call the Windows Runtime library. How to call Windows Runtime? Using the Windows Runtime library. WRL for short. WRL is basically a template library that makes it simpler to deal with some of the common idioms used by the Windows Runtime, and makes it easier for you to go author Windows Runtime components. It also provides some of the facilities that Windows Runtime components need. For example, reference counting, an equivalent of ccomp pointer, for example, an autoref counted pointer. It would provide a template class that does that. So it has a few template classes that allow you to use components as well as author components. We created WRL mainly to be consumed by the Windows team. The Windows team has this thing where we're going to lock our tools before the first day we start. We're not touching our tools until we're done, because every time we touch our tools, we have to reset things, and Windows is millions and millions and millions of lines of code, and we just don't want to keep resetting the tools on that. So at that time, we did not have option 1 at all. We were still working on option 1. In fact, option 1 relied on what Windows was going to create in the Windows runtime itself. So it was sort of a circular problem. We could not create a new language extensions before Windows did their thing, but Windows needed a Windows runtime library to help them do the runtime. So one option is you can target anything in the Windows runtime using a Windows runtime library. It's the lowest level that you can work at, very performant. If you really care about full control, that's what you get. But you're exposed to the guts and glory of the Windows runtime, including H results and everything related to that. The other option is, and that's really the option that we think most people are going to want to use, is what we call the C++ component extensions. So we said, okay, well, you can call the Windows runtime from C++, either using a library like WRL or even calling it manually. You could just, it's all C++, you can call anything. We went and looked at some of the most important aspects of the Windows runtime and tried to add language features that make this simple. Make it, if you've ever looked at COM code and with all the cascading, H result checks, it is not the prettiest thing. And also in modern times, we like exceptions, and we think exceptions are a way for you to do proper destruction, but also still maintain readable code. So how do you do that? So we tried to simplify some of those comp semantics and add some language extensions. And basically, I'm going to spend the rest of this presentation talking to you about the language extensions that we are creating. So the key things about the language extensions is that we took the type system for the Windows runtime. The Windows runtime has specific types that it works with. They have their own string class. Integers look a specific way, and we use that same type system into the C++ component extensions. We also did two things. One of them is ref counting. We automatically handle that for you, so you don't have to carry about doing your add refs and release manually. We do that for you automatically through the language extensions. And the other thing is, while the underlying mechanism is all H results, we actually expose a nice object-oriented, exception-based model on top of that. The two most important things that we added are auto ref counting and exception-based model. And that's it in a nutshell. But the most important thing for us as well was that when you use these language extensions, it all felt like it was part of C++. So it was very important that we continue to interact with the rest of normal STL types. Everything works in terms of standard libraries, a deep integration between the WinRT types and the standard C++ types, so you can easily use that in your application without having to feel that you're going to something completely different. The last thing that this new language extension adds is a way for you to provide binary compatibility across modules. One of the problems that we've had in C++ was pretty much the safest way to expose something across a module, say between one DLL and the other, was flat C. Really, when it came down to that, nothing beat flat C in terms of how to expose a method from one place to something else. So WinRT provided, because it's basically COM-based, it provided a way to be a binary, an ABI for the components that you create. And we wanted to make sure that in the language extensions that we create, we expose that binary model such that you can create a component, use it in a different DLL, use it in a different DLL written by a different language if you wanted to. So this is the most important slide in the whole presentation. So I'll let you look at it for a second. If all you wanted to do was look at the few thousand Windows runtime APIs and call them from C++, this is all you need to learn. A new pointer type that we call the hat, as well as a different kind of new called ref counted new. These are the only two things you would need to know about if you just wanted to call Windows APIs, simple Windows APIs. The way that it works is the hat is a pointer that knows how to deal with automatic ref counting and implies that exceptions are going to be thrown. And ref new is basically how you instantiate one of those things that are pointed to by that handle. Okay? So let's say in this case, we have a handle, a hat, P. It's a null pointer in line 1. Nothing has been created. Nothing has been pointed to. Line 2, we're starting a new scope as a C++ scope. In line 3, we are creating a new one of those Windows runtime objects that we care about, right? So now, new P is a handle pointing to that person object that is actually a Windows runtime ref counted object somewhere in that very nice new Windows heap. So now new P, that object has a count of 1. You go and modify something inside that, nothing changes in the ref count on line 4. Line 5, you decide that the original P pointer from the outer scope, you're going to assign that. New P is going to be assigned to that. So now if you think about the new ref new person object that we created on line 3, now another pointer points to it. So you have 2 pointers pointing to the same object. So we just increase the ref count. So ref count is 2. Line 6, we're going out of scope again. New P is no longer needed. It gets destroyed. Well, we're not going to destroy the object because the ref count is still not 0. Assign P to something else. P no longer points to that object. We know that object is in memory out there and nobody's looking at it. Ref count is 0. We automatically call the destructor if it had a destructor. How is this different from garbage collection? Who thinks this is the same as garbage collection? A few people do. Okay. Well, it's not. Here's the difference. One more person thinks. Yeah, was that a question or was that yes, you think it's garbage collection? I'm sorry? It's a question. Yes. Okay. The question was, why do you do this with a language extension and not just smart pointers, right? So we do this with smart pointers too. So if you really care about not using a language extension and just using a smart pointer, you can use WRL and it will have the smart pointer. The reason we believe doing this through a language extension is actually better is, in addition to people don't like the angle brackets, too many of them. The other reason is when the compiler actually knows, when it's not just baked in the library, when it's in the library, it's abstracted from the compiler. The compiler doesn't know. But when the compiler actually knows, then the compiler can start doing some really nice optimizations. For example, we can tell, if you are, assigning something a couple of times, and we can optimize an add reference and say, you know what, this is going to be used here. I can just take away that add ref and optimize a call to an add ref, for example. So we can do some optimizations that we would have otherwise not been able to do. And when COM was something that some people used sometimes for some of the APIs, it was okay to live without deep optimizations for that. When it becomes every call to an every API in Windows, we really care about optimizing that. So that's why we wanted to make it in the language. All right. The reason this is different from garbage collection is garbage collection at line 7, what it would do is ref count is 0, but the object may still be in memory. There's no such thing as a destructor being called or anything like that. Let's say, this actually was holding a connection to a network port, for example. And in your destructor, you would call something to close that connection. Well, that wouldn't be called at line 7. It would be called at some point in time after line 7. We know that. When the garbage collector thinks that this is the appropriate time that nobody is going to want that memory, we can reclaim it. The age and the size of the object and all of these things come in as factors, and what else is going on in the system comes in as factors. But with C++, it's deterministic destruction. You know that at line 7, when nobody points to it anymore, it is gone. The destructor is executed just like you expect with C++. So this is a laundry list of all the things that we actually added. So I told you the previous slide was all you wanted to know if you just wanted to call simple Windows APIs. But if you wanted, we're C++, we like to create things. So if you wanted to go and create some of those WinRT objects that others are going to use, or you wanted to use some Windows APIs that do more than just take 2 parameters and respond with a result, you're going to need to know about some of these. So when we looked at the Windows runtime, we just broke it down into 3 pieces. Number 1 is basically anything that we need to bind to breaks down into those 3 pieces for us from a language perspective. Data types, classes, properties, and delegates, and fancy pointers, and things like that. How we are going to allocate things, where are they going to be allocated? So we added ref new for that. And then how we are going to point to the things that are being allocated. So we added the new pointer types for that. Okay, so this is what you want to know, and I'll actually go through these in the next slides. I will just go really quickly over this slide. We're not saying that we should go and start using WinRT everywhere. That's not what we're saying. What we're saying is you need WinRT when you're talking to Windows, or you need WinRT when you're going to expose a surface area for other languages to call, or perhaps even from other components in C++ if you think that is the right way to expose it. Let's say across a module boundary. But really, inside your C++ applications, you should continue to use standard C++ with all the standard C++ types. There's no point in going and using now go change all those references to std w string and please go change them all to the WinRT string. Do not do that. That is not the right thing to do. Just keep using standard C++ internally. Between your C++ components, continue to use standard C++. So only at the boundary when you're talking to a system that uses WinRT like Windows, or another language that expects WinRT as the contract between the 2 different modules, then you start using WinRT. So let's go some more details on the actual language. So this is a sort of a less simple API from Windows that you might want to call. Okay, let's think about an API that needs a callback. Okay, so here's the case. If you look at line 2, for example, I want somebody to pass me in my function a handler. How am I going to pass that? So WinRT has the concept of a delegate, which you can define on line 1. Delegate is basically a signature for a certain function. You can go and say, I want all those carousel init done handlers to return void and to take this type of parameter. And then you can pass it as a parameter and go and say, somebody's going to pass me one of those delegates so that I'm able to call it on line 13, right? So now you'll see that you need to use a little bit more of WinRT than you wanted, even if you're just calling some Windows APIs, right? So what are those things that you can do? Well, first let's start by the simplest thing, which is creating one of those runtime classes. It's actually pretty simple. The way that you do it is you add ref in front of the class name, in front of the keyword class. So ref space class is another keyword, is a new keyword. And when the compiler sees ref space class, it knows, it's one of those fancy new WinRT classes. And that means that this class, when it gets created, we're going to do these nice ref counting things to it. And it's going to exist, its lifetime is going to be managed in the traditional C++ way, but I'm going to involve the Windows runtime. Okay? And the visibility for those is, just like C++, public, protected, and private, we also add internal. Anybody familiar with internal from the .NET world? Yeah, behaves pretty much like that in Windows runtime, actually. The Windows runtime borrowed the concept from there, which is a visibility across modules, basically. The important thing to notice is, in a ref class, a Windows runtime class, internally, all your private, all your internal methods or properties can use any types of parameters, any types of types you want. In the public surface area, any WinRT type that is going to have, any public WinRT type is going to have a public surface area. It can only expose Windows runtime types. You can't just go put a std w string as the output string, output parameter of one of the methods there. Why? Because other people using Windows runtime are not going to be able to understand what that is. The Windows API that takes a string is not going to be able to understand what that is, right? So that's why a Windows runtime string exists. This class now becomes a binary safe class. You can actually expose it across a module boundary, and you can call it from somewhere else in a binary safe versionable way. The way that you use one of these classes is just like I showed you in the previous slides. You have a hat, and you have a ref new, and then you can call its methods. The way you create one of them is just add ref in front of the keyword class. Similarly for interfaces, it's another concept. A interface is basically a way for you to define a contract. And we can do those with C++ classes anyway today. You could do class something and they say public virtual my function equals 0, and have a class that only contains virtual functions that are not implemented, and that's your interface. It's basically the same as that. So that is what a WinRT interface is. You can define the interface by using the keyword interface class. And by definition, you don't have to do virtual and equals 0. If you want, you could, but we will just put them for you because that's the only thing you can do. If you try to put an implementation there, we will complain about it. You can have another interface inherit from that or implement that interface. Inherit from that interface. So for example, in this case, a special type of animal that also exposes another method that you can call. On the lower right, you can have a class that implements that interface, right? You can go and say, now I have the class cat. And the cat knows how to do these things and specifies exactly how they're done, so that on the bottom left, you can go and say, well, I want a new cat, right? And the pointer you get back, or the handle that you get back, can be a handle to a cat, or you could just get it from an interface handle. It will give you just the play method of that. If you're familiar with COM, this is where you do things like query interface, for example, right? And this is one of the optimizations that we do. Let's say if we never knew anything about how these things were implemented, if you called, let's say, both play and scratch were members of the same interface. If I called animal arrow play, then animal arrow scratch, every time I'm calling them, in the implementation, I do a query interface, make sure that I have the right thing, and then make a call. But because I know exactly how these things are implemented, I can go and say, hey, I'm doing this same query interface, and I know they're both defined on the same interface. I can actually skip one of them, so we can actually get better performance. So when I told you all you needed to know was the hat and the new, that was right. But you could also get away without knowing those if you wanted to. You can create C++ classes on the stack, right? You can go and say, person space p. You didn't even have to do person hat p equals ref new person. You could just do person space p, or in this case, database connection db. What is happening here behind the covers is, of course, we're not putting anything on the stack. This is still the same as if you did a hat and a ref new. We just capture the same C++ semantics. So when you get out of scope, you get unref counted, right? So you can get that. Nice thing here, this is a nice example because in database, for example, you care that when you get out of scope, the database connection gets terminated. That's an important thing. That's one of the values of C++ is that, at termination, the resource management can happen at destruction as well. So it's very deterministic. So that's how you do it. The same thing for member lifetimes as well. So if you had a class member that was a database connection, we will do the same kind of magic for it. We also created the concept of properties. And a property is basically a field that you can set or get. And there are trivial properties like the one on top. You can say just property string hat name. String hat is the Windows runtime string. And what we will do for you is, you are not specifying any special way to set or get that, so the compiler internally will create a backing store for a name. We'll call it, my random backing store name 001 or something like that. And then every time somebody tries to call your runtime component and access name, you will call the artificially generated getters and setters for you. So we create the backing store and the getter and setters automatically. If you actually wanted to control how that is done, it's pretty simple. You just use that. You create a get and a set function inside the property scope. And then in the implementation, you can do whatever else that you want. The normal trivial ones would just basically do return and assignment. This one is doing a couple of other things, right? And the way that you use a property then is just like a public field. That's exactly how you're using it, except you can use it across a module boundary or across a language. Now everybody understands it. I touched on delegates before. And you can think of delegates as just a way for you to, the equivalent of function pointers, in C. And this is how you define a delegate. You do a public, and then the keyword delegate, and then you specify the signature of the function that you would want. And then the way that you instantiate one of those is actually using any of the methods that you can instantiate that in C++, just like what you would expect, really. How many people are familiar with the lambda syntax I'm showing there? About half, more than half. Okay. Well, lambdas are you could be familiar with lambdas from other languages as well. They are not a C++ novelty. They were actually a new feature of the C++ 11 standard. And they allow you to create functions with no names in line on the spot. That's the way that you do it. If you want it normally, sometimes you want, for example, you're using an STL algorithm, and you want to provide a function to compare something. Normally, you would have to go create it outside and then provide a pointer to it and then pass that as a parameter. This really nice syntax there allows you to, well, I'm really only going to need it once. I might as well just put it where I need it. So here in this case, ref new property changed needs to take the delegate. I could just go create a delegate on the spot with a lambda. These two square brackets tell it this is the start of the lambda, and then you can see just the rest looks like a function. You got parameters, you got a function body, and you're done, right? So you can create, you can instantiate a delegate from a lambda. You can instantiate it from a normal function. So basically, the lambda becomes the equivalent of that normal function. This would be the address of a global function that you have, for example. Or you can instantiate it with a class member. You give it the instance and the name of the class member, and you got it. When you invoke one of those delegates, so here we assigned p equals something. Now we can call p directly as if it was a function, just like a function pointer, basically. Auto is one of those, I did not touch on it yet, but auto is one of those other very nice C++ 11 features. It's handy. It tells the compiler, yeah, whatever the type of the thing on the right is, make that the type of the thing on the left. I don't have to write it. It's very handy when you do something like a map of string, comma, int, colon, colon, iterator, blah. Just say auto I equals. And the compiler knows what it is. Why force you to type it? So that's what it is. Because if you really wanted to know what the type of that thing is, it's all that delegate, and typing that here is pretty complicated. So auto is one of those new C++ features. This is standard C++. This is nothing invented by Microsoft here. Events are a nice way, basically, to combine delegates and properties. If you wanted a property that was of type that would take a delegate, you could create that, but then all you'd be able to do is set it or get it. But with function pointers, really what you like is, add more handlers. You think about it as a handler. You have an event and you want more people to subscribe to this event. So we add those special functions, which are add listener, as somebody listening to that event. Or you can remove any of those listeners. So you can basically create a chain of listeners and remove people from that chain. Or you can raise the event so that all the current listeners are notified. So you can create, again, a trivial event, in which case we will automatically implement all those methods for you. Or you can custom design how people get added and removed if you want. Subscribing is very simple. You just do, the event plus equals, and you just add a delegate to it. Now that makes that delegate one of the listeners. Every time this event is fired, is raised, this delegate will get notified. To unsubscribe, you use minus equals. I have the thing here about the token. It's just a special way if you actually want to unsubscribe, you need to hold a token. That's one of the restrictions of the Windows runtime. It's just how Windows runtime works. If you want to be able, most people just want to add a listener, and then when the thing gets destructed, all of them go away. But sometimes you need control and to remove things, in which way, the only way to do that in Windows runtime is to keep those tokens. Know who's added, and every time you've added them, keep a token. So we'll talk quickly about exceptions. So nice object-oriented model. So we're also exposing a very nice exception model on top of it. Everything in the bottom is H results. So it's just the standard com H results actually from the right, top right here. And those get mapped to a type that inherits from the base platform : exception. So platform exception is the base type. And then every H result that is exposed in WinRT gets its own type. And that could get thrown. So every time across the WinRT line comes a E pointer. On the other side, when C++ compiler, when the C++ runtime sees that, it translates that into a, in this case, what did we say, the pointer? It'll be a null reference exception. And it'll be thrown at the other side as that. When you catch, you can just catch that specific exception, or you can actually catch regular com exceptions and get the specific, you can throw regular com exceptions and give the specific H result if you want to. We also do generics, and it's a way for cross the WinRT types to do generic components. Pretty similar to what you can do with C++ templates, which are also supported and coming in the next slide, except that these are actually ABI safe, so they can be passed cross-boundary, where templates cannot. But of course, they don't have the nice flexibility of templates of doing all the nice compile time things that we're able to do. And this is how you specify how to use a generic. You basically say generic type name T, type name, whatever the types you want, however many generic parameters you want. And then you specify your class and you use those generic types. When you're using them, you just specify the actual types and they will get mapped at runtime. Templates are also possible. In fact, we can mix templates with the generics. That iPair that I use, which is the generic type that I used in the past slide, I can take template arguments and assign them to that generic type. And that would also work in C++. One of the key concepts here is that we're saying these things happen at runtime. For that to actually be enabled at runtime, as you're compiling your components, we actually create metadata files. And these metadata files get deployed with your DLLs. And it's those metadata files that allow the Windows runtime components to actually know what's in every type and what's happening. Excuse me. So, for example, just to produce them, you don't need to do much. As you're compiling any C++ project that contains ref classes, we will automatically generate them for you. If you want to have a DLL that only exposes those, you can see here in the bottom the C++ WinRT component DLL template. You just file new project, C++ WinRT component DLL, and you're going to get that working, already set up for you. If you have somebody who created a component that you want to use, or some component of Windows that you want to use, you just add a reference to that in the, from the Solution Explorer, adding a reference. Or if you want to do it in code just like you can do pound include, we have a pound using. Pound using the name of the component .winmd, and that would work. We also added partial classes. And the main reason we added partial classes is to enable the XAML scenario that I explained to you before. In the generated header file, you have parts of the implementation of the class. In another header file, you have the other parts of the implementation of the class or the definition of the class that you actually care about. And the restriction in C++ is that, of course, this only works for WinRT. It's not for all of C++ at this point. And if they're both in the same compilation unit, it would work. So that way, so think about the top half as being in one header file and the bottom half in a CPP file or in a header file that includes the top one. And then they can both refer to each other. So in a nutshell, that was the new features that we added to the language. We added a couple of things in the library space. So think about the Windows APIs. Some of them need to take like an array or a vector or a map. So they created containers that are specific WinRT containers or WinRT collections. So they created vectors and maps. And similarly, we exposed those for you in C++. And actually, the way that they're implemented in C++ is that they're implemented on top of the standard vectors and standard maps. That's exactly how they're implemented. So every, platform : vector, which is the WinRT vector, internally, there is a stud : vector that is doing all the heavy lifting. Similarly for maps. You can always go to the underlying vector. You can create a new platform vector from a stud vector. You can use some of the new features of C++11, like move semantics, R-value references, to even avoid the copying. So if you had like a stud vector v, and you want to create a new WinRT vector from that, you can just pass v as the parameter in the constructor. Instead of just passing p, you pass like stud : move v, and that will automatically assign ownership in the other one, and you can completely avoid the moves and copying. One of the features of the vectors and the map is that they're observable in WinRT, which means you can actually get events when somebody changes them, which is a behavior that some of the Windows APIs rely on. But it also makes the vectors and maps of WinRT slower than your stud vectors and maps. So that's why you don't want to go and replace what you have with the WinRT stuff. You only use them at the boundary, as we said. So we covered the vectors and the maps here. Finally, vectors and maps integrate very well with STL already. On the right here, I'm showing you, how you can assign them from each other. But on the bottom left, I think, is the most interesting part of the slide, because if you look at that sample, here, for example, you have a vector, one of the WinRT vectors. But if you notice, everything from the second line to the bottom is exactly what you would write for a stud vector, for a normal vector. You don't care what v looked like. All the standard iteration patterns, all the nice algorithms, standard algorithms that we have, they equally work well on standard containers or WinRT collections. So that was it. Basically, in summary, I'm very excited about how it's possible for C++ developers to create Windows 8 applications that are very compelling. So when it needs, the power and performance, we've often used that as a crutch for saying, yeah, well, that means you've got to use the harder tools, and we don't really have this, and you don't really have that. So we actually feel we currently have good Win8 tools that are on par on every language, but with the addition of the great value that C++ provides. Provide a new UI framework that's very interesting. I encourage you to go and try it out. We have new extensions for you that make calling WinRT simple. If you don't like language extensions, you can use a library, and that would also work. A lot of documentation. It's going to be in the slides that you're going to get. Click on those. There's a lot to read and a lot of Channel 9 videos to watch if you want. There's actually, I just wanted a quick announcement. There's a Belgian C++ user group just starting. So if you're interested, just send an email to this email address, bcpp@becpp.org. And I think Mark right there is actually the person organizing it, so you could talk to him as well. He's going to be in the meet corner right after this session, so you could talk to him as well. It'll be a nice way to just get C++ developers together and talk, and we'll be in touch as well. So it'll be a nice way to get in touch with people from the Visual C++ group too. And in Microsoft, we are always interested in talking to customers. Just one of the reasons why we come here and talk to developers like you is that we really care about getting feedback from our customers. And one of the things that we do is we have a usability team that comes and talks to C++ developers and understands, how do you do this? And if we did this, what does it look for you? And we're planning on doing something that looks like that. So you get early notice of some of the things that we're working on, but your feedback also, helps with the product. If you're interested in something like that, this is a URL that you can go to at the bottom here to sign up for some of those. We have some of the members of our usability team are going to be in Europe in the next few months, and they would be interested in meeting with C++ developers. If you're interested, we'd certainly love to talk to you in more depth. And looks like we also have a nice event in Belgium for Windows 8 coming up. You'll have all of those in the slides. That's it. Any questions? Yep.
Is any of this still using old-style comp variants and Eastern under the hood somewhere, or is this a completely parallel world?
Okay. The question is any of this using comp style beasters or variants under the hood somewhere, or is this a completely parallel world. We've borrowed a few things from COM internally. There's still unknown and still a bunch of stuff. But no, like the H string, for example, has no relationship to bster whatsoever. We can talk about that in detail a little bit more, but currently no iDispatch-like mechanism exposed to you, but it's not like they won't be in the future.
I also saw that the APIs have generic variants. COM didn't have that. How does this map to COM, the generic style interfaces?
Yeah.
Binary.
So the question is, for some specific thing, in your case, generic variants, how does that map to COM? We really don't try to do a lot of mapping between COM and WinRT at this point. Like, we think of them as two worlds a little bit, and not a lot of things mix right now. We did not design the C++ component extensions to enable you to use both COM and WinRT and to move between them. That might be something we think of in the future. It depends on the feedback we get. But for now, we think of the component extensions just for WinRT. I saw another hand go up somewhere too.
You have this ref class. Are there any limits on the inheritance?
Excuse me. You have this ref class. Are there any limits on inheritance? Can you inherit from one? Can a ref class inherit from another ref class?
No, can you inherit from two ref classes?
Okay, can you do multiple inheritance in ref classes? You can do single inheritance, but you can't do inheritance. But you cannot do multiple inheritance. No.
Actually, we're sharing some style and component the reference Silverlight. It's not that easy because there are some differences. And the XAML, the XAML is very different or the same.
So we're using some XAML in WPF and Silverlight, and we try to share some of them. If we did something with C++, can we share that XAML too? One of our design points was to make sure that we make that as simple as possible. It is not 100%. You can't just copy paste and expect 100% to work. But yes, you can reuse quite a bit of it. Questions? All right. Well, if you have any more questions, the last one. All right.
Only work on Windows 8 or also for example Windows 7?
Does what work on Windows 8?
The XAML library.
Ah.
Can you also use it on Windows?
Great question. The XAML library, can you also use it on an older version of Windows? I wished, but no, you cannot. XAML is strictly for Metro-style applications on Windows 8. And Metro-style applications are not available on Windows 7.
It's also not possible for desktop applications.
It is not possible for desktop applications. It's currently not possible for desktop applications. But that's something we would like to hear feedback about too. So perhaps after the session, I'm happy to talk to you about what you have in mind with that question. It's good feedback for us. But currently, the way that we designed it is strictly for Metro-style applications. There's not a lot of technical barrier that prevents us from doing that perhaps in the future. It'll be work, but it's good to understand what the customer need is. All right, well, thank you very much. I'm going to be outside in the meet area. After that, I'm happy to talk to more of you as well. Thank you.